All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, tonight is going to be kind of a two-parter, not really a two-parter, but I'm going to run this code that we ran last time when we ran the 30 epics. I actually upped the epics to 69 because with the 30 we got to 99%. And I tried it with a 40, we got to 99% still. I tried it with 50, we got to 99% again. And I tried it with 60, we got to 99% again. So I'm going to leave it at 69 and see if we can make it to 100% in under 70 epics. Now, also, we went over the process of adding filters to our images. So let me get and show you how we actually did that with the code that we started running tonight, or the code that we wrote tonight and that we're going to run. So let me get down to that. Here it is here. So it's not a very long code, but it is pretty interesting. So we're going to get ahead and pick it up where we left off. So if we wanted to detect the boundaries between various different objects inside of an image, for example, we might use a filter like this, which is able to tell whether the level of a pixel is different from the values of its neighboring pixels or greater than the pixels that happen to surround it. And so we could use this in terms of image filtering. When we can see an example of this in a code we write to formulate this. Now these are the inputs we need. These are what inputs or imports. That's supposed to be imports. Sorry about that. Let me actually go down. So these are the inputs we need here. You see we have the math, the sys, and the pill for image and image filtering. And this is this time we add Python's image library, the pill as well. So this is here. This is Python's image library. That's what the PIL stands for. And then we make sure we have the usage or ensure the correct usage of our code here. So we have if len sys.argv doesn't equal to system exit. That means I would explain it to you, but it's really irrelevant to this code that we're running with the filters. It is necessary to run the code properly, but it's not anything we went over in this course, so you probably won't understand what I'm saying anyway. Not to say that you won't understand, but anyway, let's move on. This is how we specify our image specifications. We open our image, and this is how we're actually going to set it up. So it's going to be sys.argv, and we're going to convert the image that we choose after the argument, after the first argument. We're going to convert that image to a RGB. And here we apply a kernel to our image. It's going to be a 3 by 3 kernel size with the value specified in the kernel equal. So let me show you what that is. So this is our image filter here, image filter.kernel. This is our kernel. The size is a 3 by 3, and the values of the kernel are -1, -1, -1, -1, 8, -1, -1, -1. Now imagine if we have a 3 by 3, this would be the first three values, -1, -1. That'll be the first word or the first three values. The next three values will be -1, 8, -1, and the last or third row will be -1, -1, -1. So that's how we set up our 3 by 3 kernel. Those are the values inside of our 3 by 3 kernel or filter. And finally, we'll go ahead and show our image using the filter.show. Let me show you the image that we're going to filter. This is the image here we're going to filter. See, we're going to add an image to this filter here by using our code. So let me get that cleared out. And let's go ahead and run it. So that's what the whole sys.argv meant. So this is the first argument here, and this is the second argument here that we have to add to actually specify that we want to add the image to our program. Like I said, it's nothing we went over in this course, but yeah, that's what we had to do. We had to add a second argument to this line here. So this is the first argument, and this is the second argument. That's what the sysargv meant. Like I said, I know that probably means nothing to you, but yeah, that's what we needed to specify to our code, let them know that we wanted to run the image. And we're going to actually apply the filter to the image here. As you can see, this is the same name as this. Where did it go? Why did it move? This is the same name as this here. So this is this here. We just moved this image down here, letting them know this is the image we want to add a filter to. And first, don't forget, we're going to run those 69 epics. Like I said, it's going to be kind of a two-parter. So yeah, we're going to run our 69 epics and see if we can get to that 100%. And then we're going to filter our image. So here we go with our epics here. Let them go ahead and go. And with this one, we're just trying to see if we can get to the 100%. Like I said, I tried 30, it didn't work. I tried 40, it didn't work. I tried 50 and 60, it didn't work. So we're going to try 69 and see if we have any luck. Hey, it looks like we made it well before the 60. And that's strange. I tried 30 and 40 already before and it didn't work. But I guess the more epics, I don't even know I don't even know what happened here because I tried 30, 40, and 50 and it didn't work. But it looks like it went well beyond that this time. And now we're going to add the filter to our image after that's done running. That's done running, so it's filtering up now. And bam, as you can see, I don't know how well you can see it, but yeah, this is the filtered version of the image that I showed you just now. So as you can see, the code is working awesomely. Like I said, this is very interesting to me. I didn't know we could do things like this. Took a regular old image and applied a filter to it right here, just running some Python code and machine learning. So yeah, that's pretty cool. And I'm assuming we can do that with any image we want because that's just the image I had on my laptop. So I'm assuming that any image that I chose, I can add a filter to, and I can actually tweak the filters to filter them however I want. We can change the color, we can change the brightness. I'm guessing we can do a whole lot more with this. Yeah, it's pretty interesting stuff. So yeah, that's what we did for the night. And yeah, so that's where we're at with that. And we're gonna keep moving forward. Yeah, things are picking up, and we're almost done with the artificial intelligence course. So I'm not sure how much is left, but yeah, of course I will keep you guys posted every step of the way. But before we do that, let me see exactly how long it took to get to that 100% with the this first part of the code here. So it looks like we got to 100% accurate around the 35 epic mark. And that's strange because like I said, I tried it on 30, it didn't work. I tried it on 40, it didn't work. I tried it on 50, it didn't work. But it seems like the more epics I added, it's training quicker because I guess it's I don't know why it would train quicker with the more epics added when it didn't even reach that far to the 69. But yeah, whatever, it worked. We got to 100%, so that's cool. So our model is training 100% accuracy on those counterfeit bills. It's accurately predicting if the bill is counterfeit or authentic, and then you saw our filtered image. So yeah, it was a pretty successful night, and yeah, we'll pick it up tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.